So we are going to do these problems that are related to light. Uh, One of the first things you should know is that the wavelength is generally given in nanometers. Nanometer is a very short distance, like it's point 0.00000, like 8 times 1, 2, 3, 4, 5, 6, 7, 8, 1 meters. So it's a very small number, and it can be written as 10 to the negative meters, or 1 meter is 10 to the 9 nanometers. It works either way. So here is a problem in which you have to convert nanometers to meter. What is the unit we are cancelling out of? We are cancelling out of nanometers and we are converting it to meters. We know the conversion factor. You can choose either or. We know the conversion factor that 1 nanometer is 10 to the negative 9 meters. So in order to do the problem, you just multiply the two numbers. So you do 650 times 1 to the power of negative 9. That means it is 10 to the negative 9. So the answer becomes 6.5 times 10 to the negative 7 meters. That's our answer for the first question. In the second one, we are converting 5.2 times 10 to the 6 meters into nanometers. The unit that we have to cancel out of is meters. So we can use the same conversion factor, that 10 to the negative 9 meters is 1 nanometer. So in this case, I will divide 5.2 times 10 to the negative 6 divided by 1 to the power of negative 9. If I divide, I get 5,200 nanometers. So that is my answer for the second question. Now, we are now using the equation C is equal to lambda times nu. So what are the variables that are provided to us? The wavelength is given. Lambda is given to me as 575 nanometers. And they want us to find out what the frequency is. Remember, the speed of light is always 3.00 times 10 to the 8 meters per second. Now, this is in nanometers, and the speed of light is in meters. You cannot have one unit in nanometers and the other unit in meters. So therefore, the wavelength has to be converted to meters. So our conversion factor here is nanometers to meters. So let's convert it into meters. 75 nanometers. We are cancelling out of nanometers. We are going into meters. We know 10 to the negative 9 meter is 1 nanometer, and therefore if I multiply the two, I get 575 times 1 second EE negative 9, and my answer is 5.75 times 10 to the negative 7, and now my answer is in meters, times 10 to the negative 7 meters. Now I can use this wavelength, which is in meters, in my equation C is equal to lambda nu. So substituting in the equation, I have 3.00 times 10 to the 8 meters per second equals, my wavelength is now 5.75 times 10 to the negative 7 meters times my frequency. So in order to solve for frequency, I will divide both sides by 5.75 times 10 to the negative 7 meters. And if I do that, I'm able to solve for my frequency, which will work out as follows. So if I put it into my calculator, I have 3.00 second EE 8 divided by 5.75 second EE negative 7, and I hit enter, and I get the answer 5.22 times 10 to the negative 10 to the 14, sorry, not negative, 10 to the 14 hertz. That is my frequency. Solving the next problem, we are given the frequency equals 94.7 megahertz. It's not hertz, it is megahertz. And they want us to calculate the wavelength. We have to again substitute in the equation C is equal to lambda nu. But before we do that, we have to bear in mind that frequency cannot be in megahertz. And so we have to convert it into hertz. What is the conversion factor? We get out of megahertz, we have to get into hertz. Now 10 to the 6 hertz is a megahertz. So we can rewrite this number as 9.47 times 10 to the negative, not negative, 10 to the plus 1, 7 hertz. And now we substitute in the equation 3.00 times 10 to the 8 equals lambda times 9.47 times 10 to the 7 hertz. And so if you divide both sides by the same number, you will be able to solve for lambda. 9.47 times 10 to the 7. And that gives me the solution 3.00 second EE 8 divided by 9.47 second E 7. If I divide it and I hit enter, I get 3.17 meters. So that is my wavelength in meters. I have asked for the wavelength in meters, and I have reported it in meters. Now, let's go to the problem on the next page. And in the next page, the wavelength is given. The wavelength lambda equals 50 meters. So I substitute in the equation C is equal to lambda nu 3.00 times 10 to the 8 meters per second equals, my wavelength is 50 meters times my frequency. So as I solve for frequency, I divide both sides by 50 meters. It's a straightforward problem, and if I solve, then I get divided by 50, I get 6 followed by 6 zeros, 1, 2, 3, 4, 5, 6 hertz, and just to 1 second. Now, moving on to the next problem. Here the wavelength is given, and it's again in meters, and it's an easy problem because you don't have to do any conversions. You're asked for frequency 3.00 times 10 to the 8 meters per second equals 5.0 times 10 to the negative 8 meters times your frequency. So I'll divide both sides by the same number, and I should be able to solve. And you have to watch out for the math in this case. One numerator has a positive power while the denominator has a negative power, so you have to make sure that you raise it to the negative power. And if I put it into my calculator, my answer is 6.0 times 10 to the 15 hertz. If I move on to the next problem, my frequency is given. Again, I'll substitute in the equation speed of light equals my wavelength times my frequency, and I will divide both sides by the frequency to solve for the wavelength. They have not specified if they want the wavelength in a certain unit, so I can report it in meters because that would be my straight off answer by solving the problem. Second, E7, and I get my answer as 4, and it's 4.0 meters, reporting it to 2 sig figs. If you go to the last problem, the frequency is given, but the frequency is given in megahertz, so you have to convert it to hertz. We know that 1 megahertz is 10 to the 6 hertz, so we can keep the number 1.005 times 10 to the 8 hertz is my frequency. So substituting in the equation C is equal to lambda nu, I get my lambda as the following: point times 10 to the 8 divided by 1.005 times 10 to the 8. I can cancel that, and this is 8. And so if I divide 3 divided by 0.005, I get my answer as 2.98. 2.98 or 2.99, 2.985 actually. 985 reporting to 3 sig figs. 2.985 meters is the wavelength. This problem reads wrong because the frequency is given here. You should be solving for wavelength. So my wavelength is 2.985 meters.